Now this next question that we're going to be doing is from section 4.3 and it's number 27. It says, sketch the region whose area is given by the definite integral, then use a geometric formula to evaluate the integral. So our integral here is from 0 to 2, 2x plus 5. And so let's graph this really quick. Our y-intercept will be 5. And our slope is 2x, so up 2 over 1, up 2 over 1. And there's our graph. And since it's from 0 to 2, our area will be this shaded in region right here. And our next section says to use a geometric formula to evaluate the integral. So first we have to look at what type of geometric shape does this look like, and we can see pretty clearly that this looks like a trapezoid. So we'll use a formula for the area of a trapezoid to evaluate this integral. And the area of a trapezoid equals 1/2 height times base 1 plus base 2. And so to evaluate this, 1/2 times our height, which is going this way, so 0 to 2, that's just 2, 1/2 times 2. And our bases are our different intercepts on the line, which is 5 right here, plus, and then we know from our slope that this up 2 over 1, up 2 over 1 is 9. So 5 plus 9. And so 5 plus 9 equals 14. So 1/2 times 2 times 14. And these 2's can cancel out, so our final answer will be 14 for the area of this integral. So for this next problem, it comes from section 4.4 of our textbook, and you can read that for more information if you want. It is question number 47, and it says, find the average value of the function over the given interval and all values of x in the interval for which the function equals its average value. So our function right here is 4 minus x squared from the interval -2 to 2. And so we know when it says find the average value that we're going to be using the mean value theorem. And to do that, there are a couple steps. And the first part is to multiply by, oh sorry, I was going to sneeze, okay. So you'll do, and this is b and a, 1 over b minus a, and then integrate your function dx, 4 minus x squared dx from 2 to -2. And so 1 over b minus a, 1 over 2 minus -2, and those negative signs will be turned to positives since it's a double negative, so 1 over 4. So that goes to 1/4 times the integral from 2 to -2 of our function, 4 minus x squared dx. And so now we get to integrate our formula. So let's keep going down here. 1/4, 2 to -2. And to integrate 4x minus x cubed, you just add 1 to the exponent and then carry it to the bottom, minus x cubed over 3. And so now we get to evaluate that at 2 and -2. So that will equal 1/4 times our quantity. 4 times 2 is 8, minus 2 cubed is also 8 over 3, so 8 minus 8/3. And so then we're going to subtract that from evaluating it at -2. 4 times -2 is -8, minus the -2 cubed is -8 over 3, so 8 minus -8 over 3. And so we're going to turn these positive right there. And so to further simplify, we have 1/4 times 8 minus 8 over 3 plus 8 minus 8 over 3. And then going a little bit further, just adding and subtracting in our parentheses. 8 plus 8 is 16. Negative 8/3 minus 8/3 is negative 16/3. And to simplify that, 16 minus 16/3 is equal to 48/3 minus 16/3, all multiplied by 1/4. The 48 minus 16 is 32. So 1/4 times 32/3. Our 4 can cancel out with the 32, and the 32 will be simplified down to 8. And our final answer is 8/3 for our average value. And next, to go on to the second part of the question, we need to find all values of x in this interval for which the function equals the average value, which is 8/3. So now we're going to set 8/3 equal to our original function. So 8/3 equals 4 minus x squared. And so now we want to get the x by itself, so we're going to subtract 4 from. Alright. Welcome again to AP Calculus AB Review. And this example problem is from section 4.3 in our textbook. And if you want some more information, you can read section 4.3 and 4.4. And this is question number 55. It says, determine which value best approximates the definite integral. Make your selection on the basis of a sketch. So our integral here is from 4 to 0, the square root of x dx. And so let's sketch that out right here. And the square root, it's pretty much just the opposite of a parabola, or the x squared. 4 to 0. So up 1 over 1, then up 2 over 4. Then we'll draw our line. And so we have this definite integral from 0 to 4. And let's just shade that in really quick. And we want to know which of these values, given here in our answer choices, will best approximate the area. And so we have 5, negative 3, 10, 2, or 8. And so first, we're going to learn how to solve it mathematically in a minute, but first let's just try it with just doing it from the sketch. And so we can sort of just count out all of our different values here. And we see there's 1, 2, 3, and then we can see they sort of come together, maybe another one, so up to 4, and then maybe 5. So it looks like our answer will be 5 so far, just based on the sketch, since we're not going to count the negative part. So let's try that, and let's see if we can solve it mathematically next to see if our answer holds up. And so from 4 to 0, our integral, or 0 to 4, and the square root of x is really x to the 1/2 dx. And so to integrate that, we add 1 to the exponent, so x to the 3/2 divided by 3/2, or x to the 3/2 times 2/3 from 0 to 4, and that will equal 2 times 4 to the 3/2 divided by 3 minus, when you plug in 0, you'll just get 0, so minus 0. And so to simplify that further, 4 to the 3/2, you cube 4 and then square root that, and 4 cubed is 64. And then the square root of 64 is 8. So 2 times 8 divided by 3. And when you simplify that further, you get 16/3. And we know that that is approximately 5, which, yes, matches up with our answer from the sketch. And so A, 5 will be your answer for this one. Alright, so now after our lovely review, we're going to start on our actual AP question. And this is the question for from 2015, number 3. And you see this graph here, and not graph, this table here. And here's some information to go along with it. It says Johanna jogs along a straight path. For 0 is less than t is 40, Johanna's velocity is given by a differentiable function v. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. Alright, so part A, we need to use the data in the table to estimate the value of v prime of 16. So let's start with part A right here. And to get the value of v prime of 16, we want to average the two values around 16. And so from our values here, we know that 16 is in between 12 and 20. So we're going to do v of